Good morning, everyone, and welcome to today's webinar. I'm Astrid, and I will talk about how to detect email spam using Elasticsearch machine learning. So just to let you know, this session will be recorded and uploaded to Skillfield YouTube channel without personal information. So firstly, let me quickly introduce myself. I'm working as a solution engineer at Skillfield. Coming from an information management background, I am passionate about business intelligence and statistical modeling, and of course, solving problems with machine learning techniques. It is a real pleasure to have you here, and thanks for joining. Here is the agenda for today. So first, I will introduce Skillfield for those who haven't heard about us before. Then I will talk about email spam, including what is email spam and why detecting spam is challenging. Next, I will move forward to explain how to use supervised machine learning for spam detection and what is the machine learning solution provided by Elasticsearch. Finally, I will run a demo to show you the process of building a classification model with Elasticstack. So if during the presentation you have any questions, you can post them in the WebEx chat panel. We will also be running a live Q&A at the end of the webinar. Okay, so let's move to an introduction of Skillfield. We are a big data consultancy and professional services company based in Melbourne. As you can see from the name, we take our professionalism seriously. Our vision is to be the field with skilled IT professionals who can solve complex problems with simplified solutions. Basically, what we do as a company include three main types of services around big data. We help our customers uplift their security detection and response capability by building a centralized security event logging and auditing platform. We also leverage the endpoint protection, SOAR, and advanced security analytics to effectively prevent cyber threats and facilitate your security operations. The second service we provide is to uplift observability capability. So we achieve this by deploying a centralized operational event monitoring and alerting system, as well as AIOps. Last but not least, we enhance our customers' data analytics capabilities through BI to AI analytics services. So a range of solutions are utilized to get deep insights from the data assets, depending on different use cases. And in the customer journey, we try to maximize our customers' benefits from design, development, engineering, to migrating, analyzing, managing, and gaining insights. So let's talk about email spam. Is it annoying when you find a number of unwanted emails in the inbox? According to research of more than 3 billion emails sent every day, at least half are spam. So what is email spam? Email spam, also referred to as junk email, is unsolicited messages sent in bulk. So many of them are annoying messages aiming to draw attention with misleading information, while some may be dangerous and contain links that lead to phishing websites or include malware as file attachments. So the one thing spam emails have in common is that they are irrelevant to the needs of the recipients. No one wants to receive spam, but filtering out them is not easy. So there are several reasons. Firstly, they just look like normal everyday emails. So Actually, some with well-designed contents can easily bypass the spam filter. And secondly, a spam detector algorithm must find a way to filter out spam, while at the same time avoid blocking legend messages that users want to see in their inbox. But it is hard to define the line between spam and non-spam messages. Moreover, the criteria for detecting spam is changing from time to time. So the automated system should be able to match evolving trends such as election news, economic crises, and pandemics. So, for example, there have been some cases reported of people fraudulently presenting themselves as WHO or the COVID-19 Solidarity Response Fund and sending in invoices requesting payment on behalf of the fund. Traditionally, spam are detected using some static rules. For instance, some have sketchy attachments, usually executables, which are scannable and blockable. Or spam can be blocked by certain sender domains and email addresses. Additionally, if an email contains too many BCC recipients, it can be treated as suspicious. However, those traditional ways do have limitations. So you can imagine that it is an tedious process to identify a blacklist of senders. Also, phishing emails do contain links, but the links themselves aren't malicious. So it is difficult for an email spam filter to click the link, navigate to the website, and determine the legitimacy of the landing page. Therefore, for the most cases, spam detection mainly relies on analyzing the content of the body message. And among a variety of solutions, supervised machine learning techniques have been proven to be fast and reliable in detecting spam. So according to the definition, a supervised learning algorithm analyzes the training data and produces an inferred function, which can be used for mapping new examples. So it means that we can teach the algorithm what a typical email spam is like and let the machine learn how to identify other email spam based on certain characteristics. Classification is one of the supervised machine learning techniques. So it is used to categorize data into a given number of classes. Here are some basic concepts related to classification. So first, a classification model is the algorithm that tries to draw some conclusion from the input value given for training. And it will predict the class categories for the new data. So in our case of spam detection, a set of examples of spam and ham emails, which are non-spam emails, is used to create a classification model. And with the model, we hope to find the underlying patterns and to make accurate predictions. Binary classification means the data can be grouped with two possible outcomes. For example, spam and non-spam. And a feature is an individual measurable property of a phenomenon being observed. For example, the length of an email body text. So it shows some common steps we need to follow when we build a classification model. First, we need to prepare the training dataset by checking missing values or confirming the dataset is not imbalanced. Next, we need to do feature extraction. So this process of extracting more attributes from raw data is called feature engineering. By telling the machine learning algorithm more characteristics shared by independent units in the data, we will be able to improve the performance of our classification model. Then we split the dataset into a training set and a test set. We use the training set to train the classification algorithm and the test set to validate the results. And by comparing the predicted value with actual values of the test data, we can evaluate the model and improve the performance. The next step will be to deploy the model and use it to tag new data. But that's not the end. Most time the model needs continuous improvements even after deployment, so that it can meet ever-changing requirements in the real-world cases. So you can see building a classification model may take a lot of time. Fortunately, the Elasticsearch provides an integrated solution to ingest the dataset into Elasticsearch and access the Kibana UI to use machine learning features. So this picture shows some important components in Elasticsearch. So Elasticsearch is well known as a powerful search engine, which can help users collect and transform data in real time. And Kibana is the front-end application which enables users to visualize and analyze data that are indexed into Elasticsearch. In some cases, beats and Logstash are also needed. So these are agents installed in different devices. So it can help ship and collect data from various sources to Elasticsearch. Excuse me. And Logstash can be a complement which supports further data enrichment. Since machine learning muscle is baked right into Elasticsearch and Kibana, we will see how performant it can be when I run the demo in just a couple of minutes. So here is an overview of the Elasticsearch machine learning. Under the Data Frame Analytics tabs, users can apply classification, regression, and outlier detection to your data for an end-to-end workflow experience across a wide range of use cases. So just like the common steps included in building a classification model, we can use Elasticsearch to prepare the email dataset and extract features. And then we can use this Kibana UI to develop a classification model based on the dataset. And finally, we can evaluate how well the model identifies spam emails and explore how to deploy the model at ingestion level. So I will show more details in the demo later. So why do we use Elasticsearch when there are other alternative tools? So here are some practical reasons. First, it is easy to use. So extracting new insights from your Elasticsearch data is as simple as clicking a button. So it means users don't need to know well about machine learning algorithms to make the model operational. Secondly, using Elasticsearch can help save your time. So if your data is in Elasticsearch, it's ready for machine learning. Some data processing such as tokenization and normalizing happens in the index time. Well, this is important, especially when you work in a startup or you need to adapt quickly for different customer requirements. And last but not least, although you may need to pay the license fee to access advanced features, you don't need any additional infrastructure. So that's why we considered Elasticsearch for building the machine learning use case. So now we can move to the demo part. As I mentioned, we will follow a few steps to build the model in Elasticsearch. And the first step is to prepare the data. So the data set we're going to use was collected from the spam sizing set. We can upload the CSV file and view the data in Kibana directly. To upload the file, if you go to the home page, and you can find upload a file option here. Well, you may also use Elastic agents to ingest your real-time log data in some other use cases, of course. Yeah, just think it's worth mentioning that. So after indexing the data into Elasticsearch with a name as email sample, we can view the data distribution in Kibana. So here's just an example of the data site. We can see that it contains fields, namely body, which is the email message, and another field named label. If the label is 1, it means the corresponding email is spam. Oppositely, label 0 means the email is a non-spam one. Also, this bar chart shows that we have around 4,000 records that are tagged as non-spam, and 2,000 records have a label as spam. And to deal with missing values in the data, all the emails without the body or label will be removed from the training data set. And after cleaning up the data, we have 5,982 records, which are ready to be used for analysis. And before we can develop the data model, we just need to do feature extraction from the data. We can use some simple scripts to add 2 more attributes to the data set. So you can see one feature or attribute is the length of an email message, and another is the number of spam trigger words in an email. Well, spam emails normally try to persuade someone to take action. We assume that some certain words appear frequently in those messages to draw your attention. Therefore, we can predict how likely the email is spam based on how many keywords presenting in the email. Just to keep things simple, we will use a short list of keywords as an example, and here is the tag cloud of the selected corpus. And in order to add those attributes as columns, we need to create an ingest pipeline to transform the data. So here is the pipeline I created to apply the scripts as well as to drop unnecessary columns. So we can create a new index for our enriched training data set using the pipeline. And here is the new data set with the extra field named email length and keyword count. So once we have our training data, we can use it to build the model. And then we will evaluate the model and deploy it for future prediction. So building a classification model in Elasticsearch is quite straightforward. So we can just access the Kibana Data Frame Analytics tab and to use the machine learning wizard. So you can see here we select classification as the job type and the enriched email, the new data site as the source index. And we select label as the dependent variable we want to predict. All the other fields will be included in the analysis. It also provides a scatter plot matrix for us to understand the relationships between the fields. And we choose 80% of data for training and use the remaining for testing. And we would just need a few more steps to add details, including the model title, to finish the creation. So here is the model I have already created. The training process will go through several phases to finish analyzing the data and generating results. So after the process is complete, we can view the results in Kibana. So if you click the view, it will navigate you to this result page. And here we can use the confusion matrix to evaluate the classification model. It shows the percentage of correctly predicted values in each category. So for example, from the table, we can see that 78% of label 1 emails were predicted as spam by the model, which indicates the true positive rate. Comparably, 79% of label 0 emails were targeted with non-spam, which indicates the true negative rate. And of course, we can also know how many label 1 emails were identified as non-spam, which is the false negative rate, as well as how many label 0 emails were assigned to the spam category, and that is the false positive rate. In addition, a ROC, receiver operating characteristic curve, is also provided. So it compares the true positive rate against the false positive rate at different classification thresholds. If the AUC, area under the curve, is higher, the model performs better in predicting the classes. Well, in reality, this model can be improved by different approaches. For example, we can use a larger size of training data or extract more features, such as the number of bigram-based keywords in an email. Nevertheless, it's an ongoing process, and there may be a trade-off between false positives and false negatives. Well, but the purpose of this demo is to focus on the process instead of the outcome. Therefore, I won't talk about too many details in improving the model. So let's say if we are satisfied with the evaluation results, the model can be deployed in Elasticsearch as a processor in an ingest pipeline to make prediction against the new data. So here is the pipeline, which calls the model as an inference against incoming data. I simulated the pipeline with an example of the data. So the example contains the email length, keyword count, as well as the email body. And based on these attributes, you can see our pipeline predict the label as 1 for this email. So which means this is an email spam. So this is the whole process of using Elasticsearch Elasticsearch machine learning to detect email spam. And as a conclusion in this webinar, we have seen what is Elasticsearch machine learning and how simple it can be when we use Elasticstack to build a classification model. So we selected spam email detection as an example for experiment, and we successfully predicted about 80% of email spam. Well, although this model needs further adjustment until it can be used in practice, it provides a starting point for using elastic machine learning as a complement to other algorithms adopted by some email service providers. And apart from spam email detection, we can extend the classification method to a lot more use cases, including identify whether a domain is risky or determine whether an application is malicious. Well, after all, the integrated solution provided by Elasticstack enables us to accelerate the process of machine learning deployment and adapt quickly to changes. So finally, it is worth mentioning that Skillfield is now a premier partner for Elastic in the APAC region. So we have been working closely with Elastic for more than 2 years on significant deployments. Our capabilities span all aspects of Elasticsearch, Elastic SIEM, Elastic Observability, as well as Elasticstack. We also have some certified consultants who support our customers' deployments and diverse use cases. And this is the end of my presentation. Hope you enjoy it. So now I would like to take any questions from you. Please feel free to unmute yourself. Thank you.